So I guess after seeing that equation, the next thing that we should do is maybe see some illustrations which will help us understand how that equation works and how to choose a main object and get to the answer. So let's go for the first problem here. So what happens in this example is, as you can see, there is a conveyor belt. This is the belt which is moving to the right hand side with a constant velocity v. There is a big hopper here, and that hopper has got some sand in it or maybe some kind of gravel, and it is dropping that gravel onto the conveyor belt. And this belt, it becomes heavier with time, because as the gravel keeps on falling, the belt keeps on gaining mass. And there are two rollers here, one at this end and the other at this end of the conveyor belt. These two rollers are operated by some kind of a motor. And so as the belt becomes heavier and heavier and heavier, the motor should keep on doing some extra work, right, in order to keep on moving the belt at the same speed v. So let me give you the statement of this entire problem here. Let us say that the hopper drops gravel on the conveyor belt at some rate, let us say 75 kg per second. Of course, there are certain assumptions that we will have to make. So what are those assumptions? One assumption that is usually made in all the books wherever this problem is given is that you can assume that the gravel is dropped at almost zero velocity on the belt. Now the thing is, if this hopper were at a certain height and if it was dropping the gravel onto the belt from a certain height, then the gravel will speed up. It will keep on moving down faster and faster, and then when it hits the belt, the gravel will not be at zero velocity. So they are trying to say that the hopper is right above the belt, so that any gravel that drops on the belt at zero velocity. That's number one. Number two, another assumption that we have to make is of sufficient friction. So if you just assume that the belt is smooth, then the gravel that is dropped at one place will never ever move forward with the conveyor belt. It will just remain there because there is no forward force on that gravel, so it will remain there, right, stuck in limbo at that particular place. But only if you make that assumption of sufficient friction, then what happens, and say that the moment the gravel hits the belt, it starts moving with the same velocity as the belt. So if you make that assumption, then you will be able to arrive at an answer to this particular problem. So two assumptions: one, the gravel which is being dropped onto the belt is almost at zero velocity. These are the two assumptions. Now how can we solve this? So your hint is that the belt seems to be a variable mass system. If the belt seems to be a variable mass system, we have to use that equation that we have found out earlier. So let's try to use that. So for the solution, you're going to use that equation, which is summation of F external plus VREL dm by dt is equal to m dv by dt. Now here you will have to define your main object. You will have to recall that in all the derivation that we did on the previous page, we called this mass as the instantaneous mass of main object. So who is the main object here? And in this particular example, it's actually pretty simple. The main object seems to be this conveyor belt on which some masses are falling down. So let us say the main object is the conveyor belt. So therefore, what are these things? So m is the instantaneous mass. We can try to write an expression for that. If m0 is the mass of just the belt alone, maybe m0 is the mass of belt alone, and if the gravel has been falling for a time t, then I can say m0 plus 75t. So this is probably the instantaneous mass of conveyor belt. I don't know the value of m0, but then you will see why that is not important. Then what is this guy dv by dt? dv by dt is the acceleration of the main object. In this case, it should be the acceleration of the conveyor belt, but acceleration of the conveyor belt is 0 because it's given that the conveyor belt moves to the right with a constant speed. So dv by dt is 0. Then what is this guy VREL? VREL will be, so you will have to focus on what are the masses which are being added. So VREL will be velocity of added mass with respect to the conveyor belt. So velocity of added mass minus velocity of conveyor belt. This is what is VREL. Now let me just assume, for the sake of this particular calculation, that there is a distance between the hopper and the conveyor belt, so that when the masses are falling down and they are hitting the conveyor belt, they are doing so with a velocity in the downward direction. Let me also take a coordinate system here. So perhaps my coordinate system will be this way. There will be the usual x-axis to the right hand side. So this is the x-axis, and there will be the usual y-axis in the upward direction like this. So I'm making the assumption that when the gravel falls, it has probably got a negative y velocity. So I can say velocity of this added mass, which is the small amount of gravel that is falling on the belt, is going to be something towards the negative y-axis but 0 along the x-axis. So this term is going to be 0 I cap minus Vy j cap minus, what is the velocity of the conveyor belt itself? The velocity of conveyor belt itself is 2.2 I cap. So all in vector notations. So my VREL will be minus 2.2 I cap minus Vy j cap. Okay, done. Now what is this guy dm by dt? dm by dt is the rate at which the masses are being added to the main object, and we know that rate, that is given to be 75 kg per second. And because the mass of main object increases with time, I should take this number with plus sign. So now I know that dm by dt is going to be plus 75 kg per second. And then I have all the components with which to frame my equation. So summation of F external. So therefore summation of F external plus VREL. VREL is this entire term. So minus 2.2 I cap minus Vy j cap times dm by dt. dm by dt is plus 75. And ideally on the right hand side I should have the instantaneous mass multiplied by dV by dt, but because that is 0, I don't even have to worry about this term, everything is 0, and I will get summation of F external is equal to 2.2 into 75 times I cap plus Vy into 75 times J cap. So if the belt is indeed moving as given in the problem, here if the belt is indeed moving such that this much mass falls on it per second, this is the constant speed of the belt to the right hand side, then these are the net external forces acting on the belt. And you will understand the significance also, because the masses are falling on the belt in the downward direction and they are immediately stopping along the vertical axis, along the y-axis. So there must be a force on those masses in the vertically upward direction. So these masses will try to push the belt down, and the belt also should start moving down, but then there has to be somebody supporting the belt in the upward direction. That's this support. And because the belt gets heavier and heavier and heavier, its velocity should keep on decreasing towards the right hand side. So there must be a force applied on this belt towards the right hand side to keep it moving with the same constant velocity, and that is this much force. And according to the assumptions that have been given, the gravel is dropped on the belt with a 0 velocity. This entire term will become 0. So Vy, if it is 0, that means the hopper is right above the belt over there. This term is going to become 0, and we are going to get a 0 here. And this term will exist, and this is the force that we need along the plus x-axis. You see that if we have inserted everything with the proper sign, like for the velocities we had, we inserted all the velocities with the proper sign, dm by dt we inserted with the proper sign. You've got the force also with the proper sign. Force automatically is some number times I cap, which is what we intuitively also knew. We knew that if the belt becomes heavier and heavier and heavier, somebody will have to pull the belt to the right hand side to make it keep going at the same constant speed of 2.2 meter per second, and this is that number. Now the second thing that they were asking to find out, the power output of the motor. So once you know the force that is exerted by the motor on the belt and the velocity at which the belt moves, force times velocity. So that will give you the answer to the second part.